With lines, it's not that hard.
Nova?
Yeah.
How much shorter are our classes?
Only like 4 minutes.
44?
Minutes, it's only like...
Yeah, it's only like 5 minutes shorter, and then we don't have tutorials today.
What? Food.
We had
That's
Friday.
what I had yesterday. I think that's the schedule. Alright, so we got a couple more minutes here. So that's how you invert it with a line. With a line, it's fairly easy. Now let's take a look at this graphically and see if this is correct. Y equals 3x minus 5. What did we just say the inverse was?
X plus 5 over 3.
Thank you, Amy. Now, what should I expect to see if I graph this?
Nothing.
Something awesome.
It's going to be awesome. What's it going to look like specifically?
A reflection of the original.
A reflection of the original line. Layla has this. Do those two lines look like they're reflections of each other? Probably not. Let's put in y equals x in a faint color, perhaps a cyan. Do they now look like they're reflections of each other?
Yes.
Okay. So I will now copy this into the document, and I will write all over it for a second. Starting in blue. So now, this blue line was the original f of
Mine is
x.
very demanding.
Pardon? Which was 3x minus 5. The purple line, which I'm not going to try and do, is the inverse, which I now have to write as f with this negative 1 of x, and it was x plus 5 over 3. And then there's my y equals x in there to test for reflection. Okay? That's the pattern with it. This can get a little bit uglier. I'll do another example just here graphically. How much uglier can it get?
I thought you just let us do stuff by ourselves.
We're getting there. Y equals x cubed. Remember that one? Looks like that. What kind of end behavior is that? Touchdown, puppet, ballerina. That's a ballerina. Okay, yes, good care. What do you think happens if you switch all the x's and y's on that?
It's a different ballerina.
What kind of ballerina?
Wait, can you give
Negative
me
X.
X?
The y equals x line?
Nova?
Yes.
Can you go over the names of them real quick?
Touchdown ballerina.
Touchdown,
Yeah.
and that's positive leading coefficient. Biggest exponent is even. Marionette, puppet, yeah, which is biggest exponent is even, but now you have a negative leading coefficient. Positive ballerina, okay, which is biggest exponent is odd, leading coefficient is positive, and negative ballerina, biggest exponent is odd, leading coefficient is negative.
Alright.
Does that help?
Yeah.
Okay. This one is. I hope not. I might.
It kind of looks like you do. But right there.
It's gonna be sweat. It's warm in here. You need to crack open the window.
It's not warm here.
Really? I feel warm. Okay.
It's
Right.
pretty long sleep.
Yeah, apparently. All right. So what?
Yeah,
Okay.
you're
What will
right.
this inverse look like? Take a guess.
Like this. Or like that.
Like a sad ballerina.
90 degrees. But what else?
It'll be on.
It'll just flip itself.
It'll flip itself. Okay. Here's what's gonna happen. Here's how I want you guys to think, and that'll help a
I
little
think
bit.
it would be sideways ballerina.
Be sideways ballerina mostly. Okay, when you switch the x and y, you've switched up with right and down with left. Okay? Because x gets bigger, you go right, y gets bigger, you go up. This is going mostly down. Okay, this is coming from down here and going to the origin. So coming from down towards the origin, if you switch that, that's going to be something like coming from the left and hitting the origin. And coming out of the origin and going up will now be something like coming out of the origin and going right. So you can sort of predict, if you switch up with right and down with left, how an inverse function is going to behave. What do you think the actual inverse function is here?
X equals.
Well, we're work it out a second. We're starting with y equals x cubed.
So then wouldn't it be
We switch the y and the x. What do we get? Actually, we're starting with f of x equals x cubed. What do we get when we switch the x and the y?
y or x equals y cubed?
X equals y cubed. Okay? Then how do we solve this for y? This is from the homework from yesterday. The last thing on it. How do you get rid of this?
Oh,
You cube root it.
Cube root it. You
You
cube
do
root
that.
both sides. So you take the cube root of x and the cube root of y cubed. What do you think the cube root of something cubed is?
Y.
Y. So we have y equals the cube root of x, which we can also write, if we want to put this in our calculators, as x to the 1/3 power. So if f of x equals x cubed, its inverse is going to be x to the 1/3. Does that make sense? Okay, you have to do some of that in your homework. Let's see what it looks like. Y equals x. Great. Okay, this calculator program only does the top half of it.
Why?
Mine's a little off. It's really annoying, and I'm honestly not sure, because it should have no problems also doing the bottom half. But for now, you have to take my word for it. Your calculator will graph both the top and the bottom. And for now, you have to take my word for it. There's a certain symmetry to this. And Amy, were you the first one to say sideways ballerina?
Yes.
Okay. But something else happened. The arms switched. This is positive ballerina. When ballerina went sideways, the arms also switched. All right? We'll talk a little bit more about how that works.
That is not on YouTube.
Do you think this is really
That's
a
now
reflection?
on YouTube.
Pardon?
That's now on
Now on
YouTube.
I know. I can't wait for that. Do you do you think it'll still be a reflection about y equals x?
Yes.
That's a trick question. Of course it will be. And you can see that in lovely cyan up there.
Thunder.
This one is being taken. By doing the sideways ballerina.
I don't think you should.
The sideways ballerina I was going to think it was actually useful. Okay.
You're done. You can stop.
Yeah, I'm going to stop this here. I'm going to put...
All the notes and play with your today.